Hello, welcome back. Thanks for coming back. Thanks for joining us if it's the first time you've just attended today. Welcome back to this Jump Start where we're looking at the hybrid cloud with System Center and Windows Azure. We've already looked at a number of different key capabilities within System Center and how they help us manage more effectively the hybrid cloud environment. And for the remainder of the next session and the session after, we're going to start to look at how we can take that even further. And we're going to start with a focus on Azure specifically and bring you up to speed with what Azure IaaS is all about, what it can mean for you, what it can mean for your business, and how we can start to integrate that with System Center. But before we go down that road, we need to make sure we clear up any questions that were outstanding from the previous session. So we just had a couple that we want to focus on. So, are you ready, Pete? Can I hit you with these questions?
Fire away.
Are you ready? Right, okay. One question from Vikram. What can we monitor, visualize on cloud services or PaaS, so platform as a service, instances? For instance, web or worker roles. And what can we not monitor? So can you give us a flavor of that based on what we saw earlier and going forward?
Yeah, so to get that visibility, we have to load the other Azure management packs for Ops Manager. So there's one for our applications, there's another for our databases. Now that does give us some availability and performance visibility. I can't give you the exact counters. I don't know off the top of my head, frankly. So that's one of those edge cases where probably twice a year I plug that management pack in for some set of developers. What you can do is download the two Azure packs.
The management packs.
The management packs for Ops Manager that relate to SQL and to the web application roles. Get the management pack viewer, MP viewer we call it, which will allow you to open those management packs in just a friendly GUI, and you can look at all of the rules and monitors and the classes, the types of objects that are discovered there, the performance data, etc. It's a nice window into exactly what you get, what is enabled by default, what is disabled by default. That MP viewer will give you a very quick window into exactly what you get with that pack and what you can enable with some additional configuration.
Okay, and the second question, following up right from the end of the session where we looked at dashboards and we looked at how easy it is to start to create your own dashboards, and Pete was showing us lots of different widgets, which was nice. Can I create a dashboard of dashboards?
A dashboard?
Nested dashboards.
There is no dashboard nesting, to my knowledge, so I can create collections of dashboards.
And group them together in a related, see them in the hierarchy.
Right. So as you saw with those sample dashboards, we had a folder that contained a group of dashboards, which is then very easy through the role-based security for me to effectively provision access to a specific group of operators, advanced operators, etc. Now, the other thing you can do is those dashboards, that dashboard view is really designed with consistency in mind. So whether I'm looking at that dashboard view in the full console, the Ops Manager web console, or we're taking that URL from the web console and plugging it into the SharePoint report viewer or page viewer control, the dashboard looks the same in each of those views. What you could potentially do is take the URL from the web console and then put some linkage out in your SharePoint support site or what have you, but there's no nesting of the dashboards themselves.
But I can do some cool stuff with widgets.
You can do some very cool stuff with widgets. So if you go out to the TechNet gallery, so we looked at the collection of widgets that come out of the box, the alert widget, performance, the performance by object that we call the top N or bottom N that shows us those top or bottom healthy or more often misbehaviors. There was performance, and then there's an instance details view. If you go out to the TechNet gallery, though, you will find a couple of additional custom widgets. There's one for creating web views, nesting a web page effectively, and another that will allow you to select a server object, and then it will pivot into a dashboard with some specific performance data like CPU, memory, and disk if memory serves. So if you want to develop your own custom dashboards, looking at something like that will give you some ideas around what you can develop.
Okay, I think that pretty much covers it. So they were the key questions that came in towards the end of that first session or the session prior, and we've gone through those now. So we'll move on. We'll start to take a look at Azure in a little bit more detail, because I think this is very, very useful as we move forward. We move from private cloud, we start to look at public cloud. It's important for us to understand just what some of these constructs that Pete introduced from an app controller perspective, what do they mean in the world of Azure? What does it look like when I've deployed a VM for an app controller? What do I see in Azure specifically? And what other things should I be aware of when I'm actually deploying workloads into Azure? And I think you're going to take us through some of that stuff now.
Yeah, absolutely. So we'll call this this session Service Delivery and Automation, or also known as the fun stuff. So we're really getting into those advanced capabilities as we move on. It's like the third part of a movie, except the sequel is better than the first two. So we're headed in at an upward trajectory. So we'll have a quick intro to Azure Virtual Machines, where we have to make the assumption that there are at least a couple of you out there that maybe haven't taken a look at Azure Virtual Machines yet, and given that Azure Infrastructure as a Service is relatively new, totally understandable. So we're going to cover off some basic concepts that will allow you to kind of hit the ground running as you light up your own Azure trial subscription, or maybe turn on that subscription as part of your MSDN benefit. We'll look at connecting to Azure both from Orchestrator and from PowerShell. And we'll look at developing Azure integrated runbooks.
Yeah, cool stuff. So a lot of ways of not only understanding how and what Azure is all about, but how we start to plug into it. System Center being a core part of that in terms of Orchestrator, and then PowerShell for those of you who've got those PowerShell skills that you're itching to get automating stuff. Pete's going to show us the way. He's going to show us the way to do that. And then look at the runbooks that are integrated with Azure, again, going back to Orchestrator. So some cool stuff. We'll touch on SPF at the end as well. So without further ado, do we want to pop back to the demo just to wrap up the previous session?
We'll actually get to the move a little bit later. I have a library that's actually offline, so I've got some things re-provisioning right now, so we'll touch back on those this afternoon.
Okay.
But yeah, so to Matt's point, we're really going to talk about how we connect into Azure and start to do some useful self-service type work and setting the stage, just as we did in part one, laying some of the groundwork for self-service delivery that's tailored to the end user audience, to the maybe even less technical folks, or when we need some sort of approval worked in there. So just as we can deploy to private cloud resources with Virtual Machine Manager and Hyper-V and vSphere, etc., we can do the same with Azure via Orchestrator, via App Controller, and via Service Manager. So we can have that same ITIL integrated self-service experience even if we're provisioning out to the public cloud. We'll have just a real quick look at that service provider foundation. I don't want to spend too much time there, but at least to give the folks a pointer to where they can go if they have interest in that topic. But let's start with just a quick level set on Azure VMs. And we don't want to get into the all of the deep details here, but to just give you a foundation and draw some parallels so you see some of the similarities with regards to Azure Virtual Machines versus some of the VM and service template and the service delivery constructs we saw in Virtual Machine Manager. So maybe let's start by talking about storage. So an Azure Virtual Machine has to have storage, right? Mm-hmm. And in the physical world, in our cloud fabric, we have a VHD that sits on a drive. In Azure, we have a storage account where we create storage containers. So those VHDs you see there, remembering that VHDXs aren't supported yet, right?
Correct.
We have to create a container to store our VHD files.
Yep.
And you can create multiple storage accounts. Do you have any advice for us on the strategy around how many storage accounts is the right number of storage accounts?
I don't think there is a specific number. When you're creating your subscription, you're just getting going and you're just starting out in terms of building some of these cloud services with some of these virtual machines inside. Generally, in the way I've been using it for demonstration, for test and development purposes, you'll be fine with the initial storage container. I don't believe there's a size restriction or anything from that perspective, but you may have geographical requirements that mean you place containers in different locations, so there could be those kind of scenarios. Yeah,
and I bring this up for a very specific reason. I'm going to mention that there's some Azure runbook samples, some Azure integrated runbook samples for Orchestrator out on the internet, out on the Cloud Builder blog. Now, all of those samples, it struck me as interesting that they were provisioning a new storage account in a container every time and then destroying that as they deleted or deprovisioned, however you like to call that. I tend, with my group, we each have our own storage account, and so you can break that down on a per team basis or an individual basis. I don't see any advantage, me personally anyway, in having too many storage accounts.
No.
We just keep it relatively simple, but in a corporate environment, that would mean maybe an account per team, perhaps.
Perhaps, yeah. Again, it's
Yep.
just going to be shaped. You've got that flexibility to shape it to your specific environment, which I think is the key point.
So each virtual machine, each VM we provision is hosted in a cloud service. So I think of the cloud service as being very much like a service instance that we deploy from a service template. So you've seen where we, with a service template, we deploy one or more virtual machines, even with machine tiers that can scale out, and that's all contained within the service instance construct, which has a link back to its template. Well, the cloud service looks conceptually, like that in some ways, in that I can have multiple virtual machines in there, I can scale out, I can configure load balancing to the VMs within that service. So I guess maybe don't overthink that one. It's just to draw a parallel. And even if you deploy a virtual machine and don't specify a cloud service, and correct me if I'm wrong, Matt, Azure is going to create that cloud service for me by default.
It can. You'll see that when we go through the demonstration. Yeah, absolutely. So you've got that up. I think one of the key things is, and we'll touch on this shortly, is the simplicity of Azure, and when we go through the interface and how easy it is to start to build virtual machines very quickly from the templates, from vanilla VMs. It's just very natural, it's very easy, and the placement and where these VMs reside within these cloud services, it will just come naturally once you start to get your head around how they're logically organized. And it's not a difficult process, it just means that it's something slightly different terminology-wise from perhaps what we're used to with VMM, managing a Hyper-V or a vSphere infrastructure on-prem. So there's just some subtleties to bear in mind, I think.
Yeah, great way to put it, actually. And we can have one or more VMs in that cloud. Now let's talk about networking for a moment. So that works a bit different than we're accustomed to.
Yeah, the key thing with networking in Azure, and when we start to look through the wizards that Pete will go through, this will solidify a little bit more in your mind. But one of the key things with networking is it can be configured predominantly in one of two ways. Either you're going to use Azure as an isolated island away from your infrastructure, where, for instance, you may spin up, let's say, 10 virtual machines, and those 10 VMs may need to communicate with each other, but they don't need to phone home in terms of touch base with your on-premise infrastructure. You may be developing an application that's purely going to live in Azure or in a public cloud environment, and they just need to be able to communicate across their network, a virtual network, that is all encased within Azure. So in that respect, we create a virtual network, as we'll see later, that is just pure running in Azure, and there's no connection, no way for me to ping from my on-premise server to a VM or an application that's running inside Azure. And they're completely islands and silos from that perspective. But the alternative is we start to think about how we can connect and make Azure and the applications and workloads we're running in Azure from a VM perspective, how can they become an extension of our infrastructure? How can Azure's practically infinite capacity, at least from our perspective, how can that be considered part of my infrastructure and I just scale out into Azure as I see fit? Well, that's where that virtual networking connecting back to base and establishing a secure tunnel between on-prem and the Azure public cloud, again, with virtual networking becomes very important. And that's essentially allows me to see my Azure VMs with their appropriate network IP addresses as if they are running locally on my LAN. So when I do ping out, it's routed through to that particular virtual machine that's actually running in the public cloud. So we've got that flexibility.
Yeah, and we'll look at a scenario here, just visualized in one of our PowerPoint slides here, to maybe talk through a scenario where that connection back to our on-prem resources to make Azure an extension of our corporate environment would make a lot of sense. Let's talk about DNS in Azure. That's a common question that we hear. So Azure provides us some DNS out of the box, right?
Absolutely, yeah. In terms of within that cloud service, and if you want to communicate with that cloud service, the DNS names appropriately are provided. If you wanted to, as we said before, communicate from your on-premise, however, to Azure, then the DNS that's within Azure is only going to take you so far. We need to have that single line of communication to be able to communicate with the individual services and VMs within there as well. So we may need to set up that tunnel between our, let's call them sites, on-prem and Azure being the second site, to enable that functionality. But in the most basic terms, when we create an Azure VM, as we'll see, it gets a DNS name that's publicly exposed on the internet. So you would use a strong password to make sure that you're locking it down. And if you were a remote desktop connecting from your laptop, for instance, over to that Azure VM, you'd be using that DNS name that's part of it. But this is different from running a domain controller in a VM on Azure. This is not quite the same as that.
Yeah, so we get what we have there is an endpoint that enables RDP connectivity to the VM, and the VM, you know, by default is going to be listening on 3389, so our default RDP port. But our service has our subscription. We've got that one public IP, so our endpoints that allow us to connect to the VMs are published on high ports, and then there's port mapping internally that maps that high port that's published, out available to us from the internet, is mapped down to 3389. So, so when we talk about a secure password and your VMs being accessible, it's not exactly dead simple for somebody to just scan for port 3389 because we're not listening on that common RDP port in that standalone scenario. So because you're going to have one IP per cloud service, and then we've got that port forwarding to enable the RDP. So let's look at a scenario. Let's talk about where an extension of on-premise begins to make sense. So maybe we have an enterprise application like SharePoint, and we want to leverage capacity in Azure, so we don't have to. Maybe we're out of hardware on site. Maybe we need a test environment. That's where this VPN tunnel you mentioned comes into play.
Yeah, exactly, and that's where that particular, and the diagram summarizes it very nicely, that particular application, that web front end, that line of business app that we just didn't have enough capacity for in our private cloud because we're out of budget, budgets aren't increasing, we've just no more hardware to run this extra virtual machine. We'll stick it up in Azure. We've got that secure VPN tunnel to communicate and essentially make that an extension of our existing network and infrastructure, and we just treat it that way. So we can very easily set that up. We can very easily then connect the line of business front end to the line of business database server that we may keep on premise, or the other application servers that make up that multi-tiered application.
Yeah, so let's talk about that VPN tunnel scenario from a couple of perspectives here. So first, the VPN connectivity itself. So there are some appliances that are available that we could purchase to place on premise to connect back to Azure. I know Cisco and Juniper are listed out there. In fact, if you go to windowsazure.com and click over into the documentation, there's a list of supported devices, which incidentally includes Windows Server 2012 routing and remote access.
Correct, yes. If you wanted to get started with this at a relatively low cost, you just need the Windows Server. Elements of that configure RAS, and there's plenty of documentation out there on how you establish that. But you won't have your System Center hat on when you're doing this. This is very much a networking element to this. So if you're working with your Cisco VPN or your Juniper or whoever on that list that Pete mentioned, or you're configuring RAS, you're doing that from the appropriate interface. But it will all be documented online to help you achieve that relatively quickly.
So when Matt's talking about Azure, he takes off the navy blue System Center hat and puts on his
Azure blue hat.
His Azure blue hat. And so and the Active Directory you see out here in the when we look at on-premise or in the cloud, the on-premise Active Directory can be extended into Azure, right?
Yep, absolutely. And there's specific guidance and information online about running workloads. I'll call AD a workload in this case. Like that within an Azure environment as well.
So I'm going to change to one more sort of picture here, and I'm going to set the stage for some discussion, because I know this, for me, was a reality the first time I lit up an Azure subscription that hit me front and center. So let's take an application like SharePoint, which we have on-premise. And maybe I want to move my SharePoint application into the Azure cloud. We have to make some decisions about scale up versus scale out, because as we're moving services into Azure, we're moving into a pay-as-you-go model, and the cost of an extra small virtual machine is much different than the cost of a large virtual machine. And so it becomes a question of, do we have opportunities where we can perhaps scale out rather than scaling up? Today we may, build on-prem our application servers to be very large, knowing that we need to scale up, 1 hour a day or 4 hours a week. So in Azure, we might look at that a little bit differently, hey?
Yeah, exactly. That's right. And it all comes down to whether you've got that capacity on-premise, the cost of what your on-premise stuff costs you. I mean, it's a sunken cost if you've already bought the servers, the storage, all of the rest of the components and hardware and maintaining it, versus an ongoing, perhaps lower initial or significantly lower initial outlay for an Azure VM, but then an ongoing cost associated with the storage, the networking, and at least networking to a certain extent. We don't charge for pushing stuff up into Azure, but pulling it out and so on. There's certain considerations to make around pricing, but the flexibility you've got is the key. So it's no longer I have to do this purely based on one specific reason. I can choose whether it's a cost thing. Do I want to spread that cost of that workload going forward? Well, Azure's a good way to do that. Do I want to scale it out beyond my physical capacity because I've run out of space? Well, Azure's a good way to do that. But equally, Azure's only located in certain geographies, so it may not be applicable to every customer who needs to have their data in a certain location geographically. So there's different scenarios, but from a SharePoint example, it makes perfect sense to start to utilize the Azure flexibility if you do need to continually scale and maybe deploy new SharePoint environments flexibly and quickly.
Yeah, and I don't want to, discount the reality that sometimes it makes sense to have a scale-up workload. SQL is a great example. But when we think about distributed applications like SharePoint, we're at that web tier. We have shared services. We can spread out across multiple machines. We could maybe look in the off-peak periods at running, fewer smaller machines and scaling out for those bursts as we go. And in a pay-as-you-go model, that's going to make for a more cost-effective way of going about it, as Matt says. And
just depends on the workload, though, doesn't it?
Yeah, and I say that for you not to try to give you advice for where you may be, months or even years down the road, but as you begin to work with Azure, as you light up your trial account, your MSDN account, if you deploy a large virtual machine with lots of storage and activity going on, you're going to spend your pay-as-you-go account more quickly.
Yeah.
So,
I mean, there's lots of benefits to putting these VMs in an IaaS environment. Think about all the things you have to do to manage, maintain, keep, and comfort your physical infrastructure, whether that be networking, whether that be servers and storage. All of that cost, if you added it all together, both in terms of initial outlay for the investment in the hardware and then the time and the skills and the warranties and all of that stuff, and added that up as a huge pot of money, especially when your cloud is, go back to your pricing model before, a huge amount of money invested, but then you divide that by the kind of VMs you're running on there and equate that to what it would cost you to run it in Azure, it may find that it's much more cost effective as you go along to run that in a public cloud environment, providing it meets the needs of your compliancy regulations that you may be subject to. There's lots of other considerations and providing all the features you need, but you would never have to worry about live migrating VMs around. You never have to worry about high availability. Azure almost it guarantees those levels of availability for things like workloads and key pieces of your infrastructure. But not every application is supported in Azure. So I can't run Exchange in a VM in Azure, for instance, and be supported. Technically, it may work, but it's not supported today. So there's those kind of considerations as well.
Great, yeah, and that doesn't even mention some of the high availability or durability we have with regards to storage with multiple copies.
Yeah, exactly. Geo redundancy and all of those those nines that we were looking for from Pete's cloud at low cost, we can get with Azure and this public cloud. So yeah, it's awesome stuff.
Yeah. So let's move on and have a look at the Azure interface. Let's get into the Azure portal and just have a look about here. We'll walk through the wizard. We can look at the gallery now directly in the portal as opposed to through the lens of App Controller where we were a bit earlier. So I'm actually already logged into my Windows Azure portal here. If you go to manage.windowsazure.com, click on portal, you get your login. So here I am in my Azure portal. I've already deployed some cloud services largely from Orchestrator. I have some virtual machines that were deployed within those cloud services. You'll notice there's a one-to-one match because I'm deploying relatively small for basis of demonstration here. Let me try to hit the right. What I really want is, I want Zoom it that's not on here. Sorry, my bad. I will zoom a slightly different way. I just want to give you a slightly more comfortable view there. So you'll notice there's a DNS name over here for my virtual machines. I have my location, so I'm deploying everything to US West because I am in the neighborhood. Yeah. You can deploy into Europe and other geographies there as well. Before I deployed virtual machines down in the storage area, I had to select my storage account, so I use this top one here most often, and I'll just, as you see here, I'm on the storage area here, and I'll click onto my storage account. and I can come down here and see my storage container. So I have to have that container to store my VHDs, and I actually have one conveniently called VHDs.
It's convenient.
Yeah, it's easy to remember for sure, and I can add more containers here, and through PowerShell and Orchestrator I can add them as well, to be sure. So let's have a look at virtual machines, and maybe we should begin to build.
Yeah, why don't we create a new one?
All
We've
right,
got
so
that massive button that says new in the bottom left. That'd be a...
are you sure you want me to push that? I'm sorry, I'm just catching my breath. I've got something in my throat here. Give me just a second if you could. So,
Yeah.
so dramatic pause here. So cover your ears, studio crew. Okay, so I'm going
That's the old Azure cough.
So I'm going to mash my palm on the big new button in the bottom here, which is going to bring me up to a couple of options. So let's talk about first this quick create option, because the quick option sort of tips me off that this is going to be quick and maybe there are fewer steps. And if I'm new to Azure, maybe I don't want to go through all of the details. So let's talk about the up and the downside of quick create.
That is
perhaps.
quick. I mean, there's a relatively small number of options there you can choose from. So give it a DNS name. So again, going back to what you said before about the DNS side, if we want to be able to remote desktop to this particular virtual machine in this case, then we're going to need to give it a name that's going to resolve on the internet, .cloudapp.net, and we can access that.
So you notice the little green check mark shows up there. If you put a name in that's not available, you get a little red X. It asks you to try again. So you can generally put in a VM and guess where something is not available. And then I'll go back and put in one that is available here. Let me give Matt his own VM. And you see here I can pick from the, these are really just the gallery options, right? So I get them in a drop down now, and then I can pick my size. So I'm going to go...
A7, please.
What'd you say?
A7.
A7.
The largest one at the bottom of the list there, because these were
yeah.
recently added. That's important. So these were recently added. If you drop down that list again, the other list, sorry, the size.
Oh, sorry, you want to...
Because we used to have just extra small, medium, and large. But as people now and more workloads come online, we're starting to see that people want to run bigger workloads in Azure, like bigger SQL databases, bigger perhaps SharePoint infrastructures. SQL was probably one of the primary drivers for that. Hence why you'll see, I think it's the A6 and A7 options there that give you A, more cores, and B, a more significant amount of memory per virtual machine that you deploy. So, but obviously at a greater cost.
Yeah, and scaling up there, Microsoft is really moving from, I don't think Microsoft is really recommending the mission critical, 1 terabyte tier 1 SQL workloads, but definitely, tier 3 and moving into tier 2. So we're getting into larger scale up.
Absolutely. As it progresses and people's comfort in public cloud grows, that's absolutely, that's the case.
You see here we put a username in here, and then we have to put a password in. So you can try to put in passwords that don't count. So I use the common password from Microsoft training courses. And it disallowed that. It said, sorry, you're not allowed to put in the password that everyone will guess. And I'll deploy to West US, which is in the neighborhood for us here in Seattle. And there you see we are now provisioning.
Yep.
So maybe let's repeat this process and not go the quick route now.
Yeah, the quick route is too easy. It's too easy. There's not enough clicks going on.
It just didn't hurt enough. So
No.
let's go back. That felt far too easy. So we will create a new virtual machine, and let's have a look at the gallery, and maybe we'll take the scenic route this time. So here I see my gallery.
Yeah, absolutely. So you see all of the list of the, let's call them templates, but Azure will refer to them more as images at this stage. And you'll see that whilst we've got a list of predefined ones with nice logos, so it all looks lovely and accessible with a bit of a description about what that OS is going to give you and where it can be located. But what you'll notice right at the bottom is that Pete's actually got an image that he's put up there as well through a tool like App Controller. So he's loaded and pushed an image from his on-premise cloud library managed by VMM, accessed through App Controller, and he's pushed that right up to Azure. So the length of time that would have taken would have largely been dependent on the size and the connectivity you had between your VMM and library and Azure in that case. But that could have taken a few minutes, could have taken a few hours. But once it's up there, we can then use that for subsequent deployments of VMs into Azure. And that, whilst we've got the list of all images on the screen here, if we'd have filtered by just my images, that disk on its own or that image on its own would have been the one that Oh, your
Yeah, actually what you're seeing there is just a VHD at that point.
So it might be in my disks then.
Yeah. So if we look in my disks.
Yeah, there it is. Yeah. So the difference between my disks and my images are ones that have been sys-prepped and ready to be templatized effectively and ready to deploy, whereas that disk will just be deployed as is, good to go.
Yeah, but I could attach that to a virtual machine and bring that online. So that could have been a running machine in my on-prem, and I think actually it was. So,
Yep.
So I'm going to go back to platform images here, and let's pick something, and we'll go through the wizard step by step. So now I need to start specifying some details. So this is all pretty straightforward stuff here.
Similar kind of information to the last quick create, without the nice descriptions so far.
I'm giving this some SharePoint-like.
That's going to be a powerful SharePoint machine, I can tell you that.
So I find that I start smaller in Azure because I get great performance up there actually. So I don't have the contention of my own test and development environment, so I can get by with less because I don't have a lot of contention in my fabric. Microsoft.
A common problem.
Microsoft has infinite capacity for me
Yes,
there.
right.
So we see here. So let's talk about some of the choices here: standalone virtual machine versus connecting to an existing virtual machine. Why would I take one over the other?
So if this was a standalone workload for test or development purposes, then you choose option one. But if this has got some kind of relationship with another VM that's on Azure, so if we select that option as just an example, connect to an existing virtual machine, it's going to ask us, okay, tell me a bit about that existing virtual machine that you want to start to link together with. So it's going to help us perhaps increase the availability, build that relationship. Maybe it could be an extra tier within a particular service.
And here's one of the key differences. So you notice as I'm selecting the virtual machine I want to connect to, it's showing me the cloud service that VM is contained within, which is kind of our tip that we're going to be deployed within that same cloud service, so we have connectivity right away, right?
Correct, yeah, exactly.
So if I pick a standalone virtual machine, that's going to deploy into a new cloud service, into a separate cloud service, and your cloud services aren't going to have network connectivity betwixt them necessarily.
No, not necessarily, no, correct.
So I'll go the standalone route for the moment. My region is still Western U.S. Availability set. This is what we
talked about before. Yeah,
Matt had talked about earlier.
Ensuring that VMs are going across fault domains. So if there was a failure of one, the other one wouldn't be taken down. So we've got that flexibility to do that.
So you see, we're going to enable PowerShell remoting here. It'll give us some endpoint connectivity, so we can do some remote magic.
So without ticking that box, the section that we're going to cover later on wouldn't be possible, I take it, where we're going to look at not only Orchestrator, but then we're going to look at managing Azure through PowerShell. Does that managing through PowerShell require that box to be ticked?
Well, so if we want remote connectivity, we need an endpoint, right? So checking that box basically lights up all of our management options.
I see.
So as you move out of your initial discovery phases of just appreciating how Azure works, you'll move into those phases where we now want to do something a little more productive with Azure. So once we've got the deployment piece down, we want to move into how can I put machines into common cloud services so they can communicate, and then how can I manage those remotely, and then ultimately how can I connect Azure back to my corporate environment. So name resolution and connectivity are just an afterthought for me, right?
Okay.
So kind of a logical progression. So you see that small VM that I deployed for Matt is already running. So that was very quick, very easy.
But we don't care what host it's on. We don't care where the storage is. We care where it's located geographically. It's in West US, but we don't know what SAN, we don't know what disk, we don't know what LUN, but that's abstracted away intentionally, just like it's abstracted away in App Controller for the most part. So we're not interested in those details necessarily at this point. But all we know is, and all we're paying for, is essentially the running state of this virtual machine and its consumption of the Azure environment.
Yeah, that's an excellent point. So that being said, the deployment process, once you have your images up there, the deployment process is actually quite fast, I've found in my experience. We'll talk about how you actually destroy a cloud service in a virtual machine later, because we want to remove everything. Something important for you to note as an Azure subscriber, so when we delete a virtual machine and we delete a cloud service, it doesn't automatically delete the underlying storage. We have
the virtual disk, yeah.
Right. The virtual disk remains, so we have a kind of a sequential process to delete the virtual machine and the cloud service, then go delete the virtual disk before we can delete the container if we've created a container specifically for that virtual machine or set of virtual machines as a cloud service. So I'll kind of call that order of operations out. And amongst the sample run books you'll find on the Cloud Builder blog, there are actually some helpers to help you provision virtual machines, but also one that shows you the order in which we destroy a virtual machine. Because the first time you try to go delete the last little bits like a container and you find that you're blocked, you suddenly appreciate, okay, there's an order I need to do this. It's not like VMM where I just go right-click and destroy and everything is destroyed automatically.
Yeah, there's a few extra considerations. But if we just stick in that interface for a second, if there were VMs that, say for instance, let's say, for argument's sake, we're not using System Center at this point, but we are using Azure, and I like this idea of templatizing and creating my own templates, but I'm not using System Center and App Controller, so I have no mechanism to push my disks or my images up there and from templates on-prem. I can do that, I can achieve that same kind of end goal of having a template, but I can do it all through Azure. So if I shut down one of my virtual machines at this stage, having sysprepped appropriately, I can capture with the little button at the bottom that's grayed out next to the delete bin on the right-hand side of the bottom bar, and that capture will ask me which VM do you want to capture. I'll have already selected the appropriate VM in the console. Capture, it will say, right, we're going to move this to your Azure Images library, go, and it will handle all of that. So you do that in a stopped VM that you've configured, ready to be a template, you've sysprepped it, you've shut it down in Azure, and then you've captured it. And that point forward, that can become one of your custom Azure templates. So that's an alternative way of doing it. And
it's a really good alternative way of doing it, because I know as we, in the early days of infrastructure as a service, set up some of our initial testing libraries, we spent hours and hours and hours uploading images and then discovered that we could actually capture online and not really having an image on-premise that we were married to. We said, you know what, let's just spin up some virtual machines. The operating system is fundamentally the same. I can sysprep exactly the same and capture those images up there and avoid all of the copy and the reality that in some of our test environments connectivity is not fantastic, so that copy is far from a foolproof operation. So
absolutely. Now, do you want to take a quick look at networks? Do you want to just click on networks down there in the bottom left?
Yeah, absolutely.
So you've got a single VM. Should we just walk through creating a quick VM network just so people can see what it's all about?
Yeah, absolutely.
Now there's a few options there.
So maybe we'll do custom create.
Yeah, why not?
So we get the full. So I'll give this a different name. So I'll create something for my. This is going to be my Contoso SharePoint Affinity group. We have our DNS server and VPN connectivity here. So this again, we can supply DNS servers, so we're not using Azure's DNS servers at this point.
Yep.
So I'm going to leave this blank. But you notice here you have both point-to-site and site-to-site connectivity. And somebody asked a few days ago, this may be an FAQ, I'm not sure, you can have both site-to-site and point-to-site connectivity. So I can
You've got that flexibility, yeah.
I can mix those up. So here you see my address space. So let's talk about IP addressing and virtual networks as we do this in Azure, because it's going to be a little bit different than what we're accustomed to.
Well, it is and it isn't. I mean, we went through in the session, the previous session, so the previous part to this course, Hyper-V network virtualization. And if you think about network virt and the way Hyper-V and VMM do it on premise, where do you think that learning has come from about how we did that? Think about all the customers who are going to Azure, they're deploying new VMs, they're creating new virtual networks. There isn't one guy or multiple people in Microsoft's data centers quickly plugging ports and network cables into ports, reconfiguring with VLANs and all of that sort of stuff. That just wouldn't scale. It would be impossible for the amount of new customers that are embracing Azure and bringing their own IP address schemes and their own networking configs, let's say. So network virtualization was a pioneering approach to solve that kind of manual problem in Azure. And then the learnings and the experience comes down to Hyper-V and VMM. So this same approach of specifying an address space, a VM network like we have on premise, helps you to define those IP port ranges just like you would with VMM for an on-premise IP pool and VM network. So whilst it's different to perhaps, let's call quote-unquote traditional networking, it's still very similar to the approach we're taking with VMM and network virtualization.
When I say it's a little bit different, I think in some respects it's even a little bit more automated, really, more than anything. So I click to add a subnet here, and you see it automatically selected the next subnet in the range for me.
It's thoughtful. It's thoughtful.
But it also blocks off some default addresses. So when I deploy something to a range, I think 4 is the first address it's going to use because it's blocking off, some for endpoint and gateway and bits and bobs behind the scenes. So we're not going to forget anything because Azure is thinking through that for us.
Correct. But the example we're going through here is just a very generic example of, and I explained it as one of the scenarios before, where you've got a set of 10 VMs, you just want them to connect together. They're not connecting back to your on-premise infrastructure. They're just running in an isolated network in Azure. And from that perspective, this kind of wizard and a little bit of tinkering here and there is going to give us that. But if we want to start to integrate with on-prem, we need to integrate with VPN. There's other options around registering DNS servers and registering local or extending local networks out there as well. All of those things are extra little considerations, well documented online, but we're just showing you a basic wizard of where you would effectively go to create these VM networks, because you wouldn't do it in System Center. Dark blue hat off, light blue Azure hat on. We'd do it in Azure, and that's how we would configure and control a lot of that stuff.
Yeah, that's a great point. So as we integrate Azure with our on-prem, moving from the DNS that Azure provides for us into integrating our own DNS into our Azure subscriptions is going to be really important to make this just an extension, so we can resolve machine names up there just as we can with our
and join
on-prem.
them to your domain and all of that. Authentication and cool stuff.
Yeah, and that's something you see in the long version of your virtual machine deploy, is we can do the domain join right there in the UI. So it's all very slightly different interface for a familiar process. And everything we're doing in Azure here is possible through the PowerShell UI.
Absolutely,
So and the technical evangelist for Azure, if you just do an internet search for Azure deployment with PowerShell, you'll find some great examples that help you sort of accelerate that process. To borrow some PowerShell scripts from our Microsoft colleagues.
Indeed. There is one more cool feature that I want to talk about for Azure.
Okay, and that is?
It's not to do with the VMs specifically running in Azure, nor virtual networks. But if you click on Recovery Services on the bottom left there, there's a new feature that's coming into Azure. It's currently in preview, as the name suggests at the top, just in tiny green letters, but we should observe that. The recovery services, there's 2 recovery services that are being provided by Azure. Number one is Windows Azure Backup, so effectively taking your Windows Server or your Data Protection Manager backups from on-premise and putting them in Azure for long-term archival storage or off-site backup. But the one I want to draw attention to is one that I think when we're creating private clouds, and we're wanting to ensure resiliency across data centers, it can be very, very useful. Think about a scenario where perhaps you've got your data center, you're working with a partner, or you've got 2 data centers of your own. One's active and hot, one's passive and as a DR site, effectively, as we'll call it in traditional sense. Windows Azure offers a new service that's still in preview called Hyper-V Recovery Manager. And Hyper-V Recovery Manager is like eyes in the sky, looking at your 2 sites, in my example, Site A, primary, Site B, DR. VMM is on both of those sites, managing the Hyper-V hosts that are local to those respective sites. And Azure can see both. And Azure allows me, through the Hyper-V Recovery Manager, to define these recovery plans that contain the clouds that we've been spending so much time talking about, the clouds and the VMs within those clouds, so that when we configure in Azure those recovery plans, and we say, you know what, the engineering cloud that's got 10 VMs, we want all of those 10 VMs, tick, 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 to be failed over in the event of a site loss from Site A to Site B. So Azure is just looking at the metadata and holding the metadata about what's going on in those sites. And should you lose a site, or should you want to do a test failover or a planned failover, it will orchestrate that. Not only the replication, software replication using Hyper-V Replica from Site A to Site B, but it will fail over those workloads from Site A to Site B as well. So incredibly powerful. It's in Azure, it's in preview, you can test it, you can play around with it, but it's not shipping just yet. But it's there, and it's another example of a cloud service.
So earlier in the year, at some of the conferences, much earlier in the year, when that question was asked, every time Hyper-V Replica came out, it seemed somebody would ask, so how can I do this in an orchestrated fashion? there you have it. So
that's one that's pre-canned in an orchestrator fashion. I'm sure you could say, well, you could do it in Orchestrator.
Yeah, so in Orchestrator you can definitely do that, and in fact out there on the Cloud Builder blog there's about a 45-minute video and some samples to show you how to do that with Orchestrator as well, with some PowerShell within Orchestrator. So this is the canned version, but I remember earlier in the year we heard a lot of we're working on something.
Yep.
And so
that's something. This is the something.
This is the something. This is the canned polished something, and certainly you can build another something very nice in Orchestrator. It's just going to be a little more work. Yep. Anything else in the portal before we?
I think I'm done on Azure.
Okay.
But it's cool stuff. It's awesome stuff that you can really start to get going with very, very quickly.
So he's taken his light blue hat on, and we're back in the System Center clothing here.
Yep.
So let's start talking about connecting to Azure. So we're going to get back to our IT Pro management roots here and talk about some of our options for connecting into our Azure subscriptions from System Center. So Orchestrator is one place where we can do this. So with the Azure integration pack for Orchestrator, I can import, effectively just register and deploy that integration pack. With regards to connecting to Azure, we have to configure what we call a global configuration, which means I am specifying my subscription ID, my file path to the certificate, and the password. So the same three elements we provided in Operations Manager, same elements we provided in App Controller. So common thread here. I get that information one time and I can take it to all of these components. So
that certificate's getting quite important now.
That certificate is fairly important at this point, yeah. So the Azure integration pack has some what we call category activities with some components here that no doubt you recognize. We looked at storage, machine images, which were those gallery images, our own images, partner images in the form of the various Linux flavors. Virtual machines being virtual machines that have been provisioned, so a fully provisioned instance. Now within these category activities, there are 63 activities that allow us to configure these primary activities to behave in dramatically different ways depending on the selections we want to make as we're deploying. One thing I appreciated pretty quickly building runbooks to deploy Azure virtual machines is there are more bits of information I need to supply initially as I deploy into Azure. So it pays to sort of plan out the strategy and understand the elements that are going to be reusable, your storage container, storage account, etc. So you can minimize the information that you're asking your end user for. You're just gathering maybe the name they would like to provide for their virtual machine, and I think it would probably pay off to be dynamically generating some of those other internal names that are not going to be so important to the person who really just wants a DNS name and connectivity.
Yep.
And that polishing will take a little bit of time for sure. So a couple of notes here. The password is forgiven, so that common Microsoft element. Some of the fields in Azure do not like capital letters. It will tell you when you're in the UI, but in Orchestrator, the Azure integration pack activities are not going to say, hey, capitals aren't allowed. So
if only we had like a little paper clip that just popped up in the corner and just told us that kind of...
if only Clippy were here, everything would be okay.
That'd be perfect. No capital letters. Close.
Now, so there is no test connection button when we set up that global configuration. Some of the integration packs, when we configure our global connectivity to, say, Ops Manager or another component, some of them will give us a test button. Azure does not. So I'll tend to just grab an Azure activity, drag it out into the palette, and connect up and get something rather than writing something, just to make sure that I have connectivity. And you can do
just
that
to test it out.
Yeah, you can do that with one activity and the runbook tester. Chances are you're going to need the PowerShell module for something, for some small tasks, and we'll talk more about that in a minute. I want to get you just running on how exactly do I connect to Azure from PowerShell. Once you've seen it, it's really quite easy for you to do on your own. So just a quick how-to on connecting to Azure from Orchestrator. I want to show you where that global configuration lies within our Runbook Designer. So this is the same authoring interface that we were working in when we were working with Orchestrator and our private cloud resources deploying to VMM via VMM to Hyper-V and VMware in session 1 on Tuesday. And this global configuration is actually a common thread across all of your integration packs. So we're going to look at it for Azure, but you'll have the same configuration capability for Virtual Machine Manager, for Ops Manager, for Config Manager, and we can, just as we can plug in multiple Virtual Machine Manager and other System Center environments into Orchestrator, we can add in multiple Azure subscriptions. So let me just zoom in here and we'll look at our global configuration. So it comes on the options menu in the Runbook Designer console. So you notice when I hit the drop down here for options, I have a lot of integration packs that I've imported, so lots of activities to choose from. And within the list here you will see Windows Azure about midway down. So
where did you get it from?
So I got that from the Microsoft website, actually.
So there's no catalog in the same way there is for Ops Manager to get these IPs?
Yeah, that's a great question. So there is no catalog option where I can pick from catalog and magically import. I actually want to go out and internet search or go straight to the Microsoft website and search for Windows Azure Integration Pack. It's going to take me over to a page that contains the System Center integration packs. Azure is there right with it.
Yep.
And some of the other IPs that Microsoft provides for even third-party components.
Yep.
As we talked about in our first session. So let's just hit the Windows Azure button here, and I want to show you a couple of things here. So the important things are obfuscated. Thank you, Orchestrator team. So as I zoom in here, you'll notice that I've given this global configuration a friendly name, just a reminder that it's my subscription. When I hit that little ellipsis out there, the three little dots, that just gives me the connection types. There's only one here, it's Azure Management. And you see I've provided the three key values, my subscription ID, my certificate, and my password for the PFX file that secures my private key. So to be sure nobody can reuse that. So that's all there is to connecting into Azure. There's like I say, there's no way to, no test button there, but we can test fairly in a relatively simple way. Now I'm going to just give you a preview here of the virtual machine deployment process. So I have a series of runbooks. We had talked in our first session around private cloud about the value of creating small function-specific runbooks. And you'll notice here I have a fairly straightforward 1, 2, 3, 4 process. And this first runbook here is what I call my parent runbook. This is where I'm actually driving all of the activity. I'm going to use that initialize data activity, which is just designed to accept input into the runbook. We'll drill down into that in a second. But you'll notice I have the invoke runbook activity that I've dragged and dropped onto my palette here. So I can call runbooks 2, 3, and 4. So create cloud service, create the container where I'm going to store my virtual machine, and then actually creating the VM within my cloud service and my container. So
you're almost nesting runbooks within runbooks here, essentially.
Yeah,
but they're hidden behind this individual activity on the canvas.
It's as though Matt knew that's exactly the word, that we call that nesting runbooks, and that's a very common and in fact recommended practice. And what I have here is what we would call the drag drop done version. I've made a relatively simple albeit functional version because the production ready version that has all of my air checking in it and so forth has a great many objects, and it will tax your eyes and your mind a bit more. I wanted to keep this just down to the bare necessities. We'll look at a little air checking, but you see it's quite simple. To create our cloud service, nothing too fancy here. I have an activity that's going to accept some input for creating my cloud, and you notice I'm using some of those best practices we talked about in our first day together. I've created branches of logic here. So if my cloud is created successfully, I'm going to return an OK result. If creating my cloud service fails, I'm going to follow that failure branch down to a not OK result. So I'm just going to drill into that initialized data activity. You see I'm asking for a couple of pieces of information here that correspond to Azure's asks around information for creating a cloud service, a DNS prefix, a description, and a label, so some logical constructs within Azure. What I would recommend you do as you're getting comfortable is literally put in a naming convention that includes those words. Like the first time I ever deployed anything to Azure with Orchestrator, like 30 minutes after this pack hit the internet, literally, I would put in like my initials, maybe my site code like HOE and then HOU, and then I would put DNS PRF. I would use my prefix and then label and then maybe an abbreviated description. But I was sort of mirroring these terms in my naming convention so I could see where they showed up in the Azure UI and to begin to make sense of those. So I guess I'm saying you don't want to get too creative with the naming convention. You want to sort of develop in your mind the pattern of when I supply this value, where does it show up in the Azure portal, and with regards to that VM and that cloud service, what is its function? So
and stick to lowercase.
And stick to lowercase.
Yeah.
Azure does not like capital letters in all. There's no need to shout. Is what Azure tells us.
And that's Azure with a lowercase a.
You may spell Azure with an uppercase A, but
right.
only when you're not speaking to Azure directly.
Yeah.
So you notice here, same sort of pattern in this run book. So in the next one, I'm creating a container. So whether I'm creating a standalone virtual machine or I'm creating a cloud service that has many VMs within it that are going to communicate, I'm building some function-specific runbooks that I can use over and over and over again, so I don't have to reinvent the wheel every time. If you weren't there with us in our part 1 session around private cloud, I said that most of my runbooks have fewer than 10 activities in them, the overwhelming majority, because I'm building very function-specific runbooks. There are a few parent runbooks that get a little more sophisticated than that, but I try to keep them as small as I can.
And the more complex they are, the less generic they can be across multiple either environments, which as a partner is very useful because you can reuse that IP elsewhere, but also even directly within your environment, using them in different business units, different segments. The more complex they are, the less transferable I suppose they'll become. Yeah,
so we say there we're focusing on modularity and portability. So like in my environment, for example, here I'll just drill down into my set of folders. You'll notice I have runbooks that we call utility runbooks. These are small function-specific runbooks related to Active Directory, little tasks I do in Service Manager, email, dedicated error notification or error logging capabilities. I use these things multiple times every time I develop runbooks for myself or a customer. And you want to develop that same sort of utility library that you coordinate with your other teams so they can leverage the same framework. And I find even within my team, we will find that something we did in our first iteration doesn't work quite as well as we want, and we'll opportunistically make that a little bit better over time. And so we get a stronger and stronger set of utility runbooks that allow me to build sophisticated automation just much, much faster as I go down that path. So fairly simple process, and just for fun, I'm going to make sure I've checked in all of my virtual machines. Let me show you a little trick here. So one of the limitations of the runbook tester, when I launch this runbook tester and attempt to test a runbook, one of its limitations is the runbook tester will not track the progress of nested runbooks. It loses the link when we call one of these runbooks with this invoke runbook activity here. So I can't test my process here with the runbook tester. So what I've done are a couple of things I want to show you. First, I've put an invoke runbook activity into a testing runbook. I use the little browse button to browse down to my Azure Deployment Runbook, number 1, my parent runbook. And what the invoke runbook activity does is it presents to me all of the inputs that I need to pass into this parent runbook to make everything run. So you see I've pre-populated some values here, so this simulates a lengthy wizard.
This is hard-coded effectively.
Yeah, I've hard-coded this, and as I want to test over multiple iterations, I just come in and bump the number up 1 as I tweak.
But how could somebody get that information in that wasn't hard-coded? What would be an example?
Yeah, so if we didn't hard code that, I could do this a couple of different ways, and I'll just show you here. One of those would be the orchestration web console. So just to make this fun, I want to go ahead and kick off one of these runbooks. You notice I'm going to check these in. So when a runbook is checked out, it can't be called, it can't be leveraged. It's checked out for editing, so to speak. Think of it as the equivalent of draft versus published in VMM with our service offering. So I think I am checked in across the board. So just so you know, when I'm developing runbooks and when you're developing runbooks, one thing I do potentially do is in the runbook properties, there's a logging tab. I can turn on verbose logging of some of the activity-specific data. You do not want to take that logging into a production environment. That's going to be bad news in terms of the size of your database, because turning on all of the verbose logging of the activity specific info and the globally the global info could make your runbook's footprint 10 times the size in the database. So that's a big no-no, once we get through the testing process. So I'm all checked in. This one is, I'm going to check in my tester runbook that will trigger the process by calling number one, which in turn calls the rest. And so I'll set that in motion, and while that is in motion, we will go ahead and launch the orchestration web console. I'll give that a second to render, but what's happened here is my tester is in progress. So if I go over to my Azure deployment runbook, I'm looking down here in the logging tab. So when I turn on that logging activity, I get logging data here in real time. When this runbook finishes, the results show up in the log history. So I'm just going to hit the drop down here and zoom in for you one more time, and you'll see that we're going through the provisioning process. So it's created the cloud service, it's created the container, and it's already working on creating the virtual machine. So this is the piece that's going to take a bit, right? It's going to be deploying the VHD, etc.
Is it going to be, which template is it going to use from Azure? Which one was hard-coded?
Yeah, so this one I hard-coded the Windows 2008 R2 template. So what I would typically do in a production scenario, and I actually can't make any changes here because you see it's running. In a production scenario, I wouldn't use any sort of default template. I would want to come in here and set some, I would want to put a menu option out there for my users so they could pick the type of virtual machine, and I would pass that in as an additional parameter into that initialized data activity.
So a good way to do that would be perhaps a service manager form, effectively from a user perspective, but a service request.
That would be
or request offering.
That would be better than a good way. That would be an excellent way to do that.
Lovely.
So an ITIL integrated way. So you'll notice here I have quite a lot of inputs with this virtual machine activity, so it's not a trivial amount of work I'm passing in, but you notice I'm creating an endpoint here as well, trying to make sure that I can connect into this at the end of the day. Local endpoint, again, being the listening port of the virtual machine, the public endpoint being the high port that we would get to it with. So you want to play around with that. You're going to need to build some flexibility into that and dynamically populate as many of these things, because as you saw in the UI, there are several values there that mean nothing to the average developer and user, because they really just want the names of the virtual machines to which they're going to connect internally. So we can maybe ask for the name of a virtual machine from them, and then within Orchestrator,
and the size maybe, and
and then maybe the size and so forth.
Yeah.
But we'd want to put those into drop down, so we're not asking for a lot of hard coded input, and then we can, based on some minimal values they give us, do everything from generating random passwords. There's an activity for generating a complex random password, true story, and generating random bits of text, all pretty easily done in Orchestrator. And if you've not used Orchestrator much, the beautiful thing about Orchestrator is not that it is so clever and that it gives us the capability to build complex, reliable, well-documented automation sequences, but it's a very easy component within System Center to learn. I'm a strong believer that anyone can be pretty good with Orchestrator in a month of Friday afternoon. So when you hit that Friday afternoon where you're not feeling like doing any actual work, flip over to your test lab and work with Orchestrator for a bit and have a bit of fun. And it doesn't even have to be serious as you're learning. There are community-developed integration packs for fun things like Twitter, for example. So I could take Matt's little jabs and I could automate those so he doesn't even have to make those jabs at me. We can put them on autopilot. I'll capture those in a spreadsheet. And
it will come back to haunt you, don't worry. Are we not going to go back to the web console?
Oh, sorry.
You built it up and then you've let me down gently there.
ADD theater, thank you. Okay, so.
Well, I was excited,
Yeah, so sorry. I build up the drama there and then I just walk away. I've got PowerShell on the brain. I actually want to. I'm kind of excited to show you how easy it is to connect into to Azure with PowerShell. So we're going to go back to the orchestration console.
The web console specifically now.
Yeah, so I'm in the orchestration web console. So this is the web UI. And I'm going to go over to the Runbooks tab here, which allows me to search for runbooks. And it gives me a little search filter here. So I can hit a drop down and put in the name of a runbook. If I know where it's located in my hierarchy, it could actually browse to it. So
will it still be running at this time? I imagine it will, won't it?
Well, so it will, and my capability to initiate this runbook to create a new virtual machine request depends on the the run behavior that I've set up here, because by default a runbook is configured so only one instance of the runbook can be going at a time. I can configure a runbook to allow multiple instances. So and you know, what is the right answer for concurrency? Let's think about that in a hybrid cloud sense, for example, with VMM. I'm only going to roll out as many virtual machines as I believe my simultaneously as I believe my fabric can support in terms of disk I/O, because the deployment process is kicking off that bits copy, right? So unless I've got significant storage down there, it may not be ideal for me to allow 5 or 10 VMs to roll out at the same time.
Yeah.
The Azure side of the house, I don't have those same worries, because Azure gives me lots of performance scalability there, so I'm going to be a little more aggressive potentially in the concurrency setting within my runbooks. But you can set that on a per runbook basis just to cover that off. And I'm going to just drill down and show you this. So I've basically, for number 3 here, which is number 3 is the second step in the process, creating the container. I right-click on Create Container, select Properties, and we have the Job Concurrency tab here, where you see the maximum number of simultaneous jobs is 1. If I wanted to allow provisioning of multiple cloud services and virtual machines at once, I would want to go through here and potentially bump these up to allow multiple simultaneous executions. But again, whenever I'm doing that sort of scaling in terms of concurrency, I want to think about the activity and what sort of load that's going to put on the target system that I'm pointed at, and pick a level that is appropriate but not really crushing that machine. So just to cover off that process here, let's go up here and look at virtual machines and see if we have anything happening yet. So I don't see anything up here just yet. So I've probably got some copy operation out. We'll come back in a bit after we do a little work with PowerShell and see what is going on.
There's that one there, isn't it? 20?
Yeah, there it is. Sorry. So yeah, I did the refresh there and it's popped in. So I have my cloud service right here, and I have my virtual machine, which is right there. And and for purposes of demonstration, I tend to do a little more hard coding. You can get pretty creative with the dynamic properties, and I've even hard coded some of these or presented these fields into a service request, so in Service Manager, so we can talk about which elements you might want to show the user and which you might want to dynamically generate in the background. I have some opinions on that perhaps you'll find helpful. But one thing I guess I want you to take away from that look at the orchestration web console, it's lightweight, it's easy for me to use, but when I launch a runbook from here, if it requires input, what I'm going to find is that I don't have any way to validate my user input in this interface. So the user can give me wrong data, and this lightweight web console doesn't give me the capability to prompt them and say, hey, you gave me a bad value here. So I really have to deal with that sort of validation and so forth in my runbook. And that's what's really nice about Service Manager, as we spoke about on day 1, was that we can collect the information from the user in a comfortable way. We can make sure that the data is valid and it's logged into a service request before we actually go deploy anything. So and I guess what that translates to in the real world is I tend to use the orchestration web console more for its reporting capability. You notice over here I can see the running jobs and the instances of that job. So you might ask, what's the difference between a job and an instance? Well, when a job kicks off, like a monitoring type runbook that's watching a folder or watching for any service request to go into maybe an in-progress condition in Service Manager, the job is monitoring, is running, and when it is triggered, it's going to generate a second instance so it can watch for new conditions while the first the first instance it triggered still runs. So you may have multiple instances out here, but you see in the UI here we get some visibility into how many running jobs and instances there are out there. We've got some historical data reporting. So over here you have some summary as well, so you can see what's happened in my environment. So this is my development environment, and you can see even in the last 24 hours, 10,000 instances. So there is so much going on in the background here automating things that it just kind of blows my mind. I'm almost a little bit surprised to see that. But that's really what you can build over time when you use that modular capability.
Is there a limit on the number of runbooks that you can run at the same time? There's a question that just came in.
Yeah, so that's a great question. So the concurrency limit for a runbook server by default is 50.
Right.
Okay, and what I want to say about that is that's a number that's been around since the Opalus timeframe, which was the product Microsoft acquired and became Orchestrator.
Yep.
That is a legacy number that is just a starting point. Don't pay attention to it. We can turn that number up, especially with Windows 2008, with Server 2012. We can turn that up into the at least 200 as a starting point, in my view. And for organizations that need to scale up, we'll turn it up to at least a couple of hundred. And we can potentially go higher. I've seen many organizations with 500 runbooks out there, and the answer for how many runbooks can I reach in terms of a scalability limit, the answer is it depends, because it depends on what your runbooks are doing. Many times, like provisioning a virtual machine in Azure, so we're doing a lot of work over there in Azure, right? What do you think the load is on my runbook server? Orchestrator is not agent-based. It's making a call. Azure is doing all the heavy lifting there. Orchestrator's just watching to see what's done. So I could provision a lot of virtual machines in Azure. I could get my Azure subscription really, really busy without putting a huge load on Orchestrator. But I've seen environments scale up to 500 runbooks on a single server and even across multiple servers that way. So you just want to watch your resource utilization. You can scale out your runbook servers with Orchestrator. We call it a waterfall model. So by default, all of our runbooks start on our primary server, and as we hit that limit, if it's 50, if it's 200, the overflow spills over to our secondary runbook server and our tertiary, and all we need to do to establish that sort of scale out is to just install new runbook servers, which is a couple of minutes with a little installer package. So the system center.
Maybe you could automate that.
You could.
Yeah.
You could. So. The better question is, what can't we automate with what can't you automate with Orchestrator is actually a much shorter conversation than what we can.
Yeah.
I have to be careful about that. I've said a couple of times, it's not can I do it with Orchestrator, it's should I do that with Orchestrator.
There you go.
So let's quickly just talk about connecting to Azure with PowerShell. So there is a PowerShell module for Windows Azure. You can download it off the downloads link on the Windows Azure.com website, and we install it just like any PowerShell module. We import it just as we would any PowerShell module, the import-module capability. And like all of the other mechanisms we use to connect to Orchestrator, the app controller console with Orchestrator, when we were connecting in, we needed those three elements, right? We needed so call them out for me, Matt. Pop quiz.
Right. We need your subscription ID.
Right.
Which is, are you going to tell us?
I'm not.
No, we need your...
Thank you for asking.
We need your certificate,
Yep.
which is becoming important, and we need your password, which isn't the standard Microsoft password, I hope.
It's not the standard
There you go.
Microsoft password.
Are they the three things?
Those are the three things.
There we go.
You passed.
Yes.
So we'll look at that, and it's really quite easy in Azure. The first thing we're going to do once we load that, we're going to download and install the Azure module. It's expecting PowerShell v3, by the way. So FYI, okay, if you have multiple versions of PowerShell, we want to make sure we're PowerShell v3. There's a commandlet. I was about to say activity. I have Orchestrator on the brain. I have Orchestrator brain. The get-Azure publish settings file is a commandlet I can run, and all it's going to do is open a URL for me and have me log in, and that will give me my publish settings file. Within that publish settings file is my certificate and some other information, subscription ID, etc. So some of those underlying details, I don't have to worry quite so much at that point. It opens a web page. I download and save this file to a secure directory. So with emphasis on the secure directory, I don't put this out on the public file share because I'm potentially opening a door for an adventurous soul to find a way to, within my organization, to use some of my Azure capacity instead of their own, and I definitely want to avoid that. So let's just look at the connection process. I'll jump back over to just a PowerShell interface. I'm a big fan of the PowerShell Integrated Scripting Environment, or ISE, we call it, within Windows Server 2012. It's really quite nice. It allows us to highlight little snippets of code and execute code in little bits and pieces. So I've bumped up my visibility here just a bit in this console. I'm going to try to make it just a bit larger because I can see Matt straining as I am. So you'll notice here on line 1 I have the import module Azure. So if I run the default installer, I find that Windows recognizes it. It's in the path. The second step is that commandlet I mentioned, which is get Azure publish settings file. So I'm just going to kick that off so we can watch that run. So we'll just launch that right here. And you see it pops open that URL, takes me out there to get my publish settings file and to save it out to the drive. I just log in, I get the file, I'm going to save it out to a secure folder, which in my case I've got a local folder here where I've got it on lockdown. And there is my publish settings file, and you notice it's got the Visual Studio Ultimate there, just calling attention to the fact that I'm using my Visual Studio or my MSDN subscription benefit here to light up quite a lot of capacity actually for free. So now I have my settings file, and I've got a 3-line connection process to Azure from PowerShell. I'm going to import the Azure module that puts the commandlets, the Azure commandlet set into my session. I have another commandlet related to that publish settings file. It's called import-azure publish settings file. I give it the path and name of my publish settings file here. That's the parameter. And then in the third line here, I set my Azure subscription. I supply my subscription name and the storage account I am working with. And I am now, at this point, officially connected to my Azure account. And I can begin to run commandlets to do various things. For example, let me just go get VM images here using the get-azure VM image. I find that the commandlets in Azure, you can almost guess what they are. I heard a guy that was using some pretty fancy words, and he says we've minimized the cognitive distance in our syntax. So basically, they've made them very intuitive. So I'm going to type get-command. I'll type module and Azure, and that would give me the capability to go get a list of commands that are in the Azure module. So they're all just running down my screen. So get-command with the module parameter, and I just type Azure, and I get a list of all of the commandlets that are available in there. That would allow me to build, to provision cloud services, storage containers, virtual machines, configure connectivity, multiple VMs within a cloud service, load balancing, all of that within a PowerShell interface. So the technical evangelists within Microsoft, some of Matt's colleagues, have put some excellent resources out on their TechNet blogs. I want to call out Michael Washam in that respect, has put just a massive amount of PowerShell fodder out there, and I feel like I owe him several beverages of his choice at this point in my career, just for all of the days that he saved me exploring these things.
You can come to the Tech Ed party that we've organised for you.
There we go. Yeah. Nice. Yes, I'm going to be buying a lot of people drinks.
Yeah,
It
exactly.
sounds like. So Matt's got a plan here.
Yep.
So that's really all it takes to connect into Azure from PowerShell. It's really quite simple, and then just go get some of those great examples. Remember the Cloud Builder blog is
the Building Clouds blog.
The Building Clouds blog is where we can find some of those PowerShell or some of those Azure-based runbook examples for not only provisioning services but also deprovisioning. Now I found with those, I had a look just before I recommended those to you guys, but they tend to they're creating a lot of storage accounts and destroying storage accounts and so forth. I found they were doing a little more in there than I like to do, and they were also using a lot of PowerShell. I like to use, as you saw in my samples, I'm using as much native, as many native runbook activities as I can, and I want to use those native activities because PowerShell, little bits and pieces of PowerShell to bridge the gap help me, but I want to minimize my use of code because I want my runbooks to be easily supportable by my entire team. I don't want to build myself into a corner where I have something that is so challenging that I and maybe one other person are the only people that can support it, because now I'm going on a journey in the wrong direction.
Just out of interest, how, if we compare side by side on paper the Azure IP for Orchestrator, the integration pack, and we compare that side by side with all of those commandlets we found in the module that we downloaded for Azure PowerShell. Which one's going to give me the most control, irrespective of how easy it is, Orchestrator versus PowerShell? Am I going to be able to do certain things in the PowerShell version or the PowerShell option that I can't in Orchestrator and vice versa?
That's the case, yeah. So the PowerShell route, and then that's exactly what I wanted to show you, that the PowerShell route is going to be a bit more flexible. And when you look at the Building Clouds blog, they were laying out kind of an elaborate scenario, so they went to PowerShell pretty quickly. And given some of the announcements we heard about the future of Orchestrator, that's not a bad thing. I find that I'm now, I still use PowerShell to fill those gaps. I'm a little less likely to go build custom activities to drag onto my palette now, unless I'm building those for a customer where they need that activity for reusability.
So you can call PowerShell into Orchestrator.
Yeah. There's with the run.NET script activity, I can call PowerShell and want to do a quick internet search to look at the examples for calling PowerShell v3 within that run.NET script, because there's a science for that. And I and quite a few people have sort of blogged our preference, our standard for how we do that. And with PowerShell remoting being so easy in modern versions, the later versions of PowerShell, I find I'm using that a lot as a standard. I don't have lots of SDK components loaded on my Orchestrator runbook servers. I'm calling out to those other servers quite successfully in production scenarios. So let's talk through that Azure, create Azure VM workflow just real quickly here. This is what we were already looking. So at the basic level, it was just the three-step process. So what we walked through was the parent runbook, creating the cloud, the container, and the VM. So we have to have the cloud service, which is where the VM resides within. We have to have the container to store the VHD, and then we create our cloud service. We create the container that's going to contain our VHD, and then we deploy the virtual machine. You notice my runbooks here are fairly simple, but they do have some air checking in them, right? So my air handling is already built into this process, and I didn't have to build that many activities to do it. So here what I'm doing, you'll notice these those little icons with the green arrow. I'll show you what those are. That's actually returning a result back to my parent runbook. It's passing back the pass or fail notice, so my parent runbook can track the activity, the progress, and the settings. So we covered off our Azure connection string. It's the three-step process. We import the module. Let me get my trusty laser pointer out here. I import the Azure module, which you can get from the download page at windowsazure.com. I import my Azure publish settings file that I retrieve with that get Azure publish settings file commandlet, and then I load up my subscription, and I'm good to go. So very easy to do. But let's talk about that runbook, the real process for automating a process, the create Azure VM process. When we're creating the cloud service, we create the container, we create the VM. Just remember, you have to have these in order. If you try to create the VM and you don't have these other two, it's going to fail. Just like if I try to go delete the container that contains the VHD, it's actually going to fail and say, sorry, I have an asset in here, and we have to go delete and empty that out. And I put this out here. You may call this optional, but I want to record my results and notify the requester. So in a perfect world, I'm tying back to my service desk system. Maybe you're lucky in that Service Manager today. Even if it's not, remember there are integration packs for some of those other popular service desk platforms. Yep. Some are free from Microsoft. Some are available from the partner community out there on the Pinpoint website, where you can find the folks that have put that together. So that being said, I want to go back and just have one more quick look within our runbook. I think we're just about all provisioned in Azure there. I think our virtual machine was up, but I wanted to just make a couple of points about the nested runbook strategy here. There's kind of a right way to do that and a wrong way to do it. So when we're nesting runbooks, it's not that it's complicated, it's that we need to do it right. And here's what I mean by doing it right. So at the parent runbook level, I've used that invoke runbook activity, and I've browsed out to the runbook, so in this case out to the create cloud service. But the magic box I want you to notice here, you see wait for completion? when I call that runbook, it's going to go do a piece of work, and I've configured that runbook to give me an answer. I'm only going to get that answer in this nested runbook scenario if I wait for completion. Key configuration item. So remember that one. Now let's go look at the child runbook we're calling, and I'm going to go into this return error activity, and you see I have a return OK activity. That activity comes out of the runbook control category over here in my my activity palette. It's called return data, and its sole purpose is to return data back to the parent runbook. So configuring a runbook to return data to its parent is a two-step process. I'm going to begin by right-clicking that runbook and selecting Properties. I'm then going to go to the Return Data tab in the runbook properties. I'm going to drill down here, and you'll notice that I am passing back. I've got a property, a placeholder for the answer called status, and it's an integer. I'm going to pass back a 1 or a 0, a binary result. I either created the cloud container or I did not. But this is going to give me a reliable way to report progress back to the parent runbook, so it knows that step 1 is done before it proceeds to step 2. So the second step in that is I drag the return data activity out here, and I configured return error to return a status of 0, and return OK is going to return a status of 1. So very true false like. Now let's look at the logic, the branching we call it. So if I look at the cloud created successfully branch, you'll notice that if create cloud service return success, we're good. So that's the default logic for one of these conditional links, we call them. But if I go to the error branch, you're going to notice that it has to return warning or failed. So very important there. I'm thinking about all the conditions, the 3 conditions being success, warning, and failure. I want to make sure that I plan for the yes, the no, and the maybe. So whichever activity, whichever branch we go, it's going to put that 0 or 1 into that placeholder, which the parent runbook can then get, and it will know that only if this is successful does it move on to the next and move on to the next. So that's your process for doing your nested runbooks in a way that's going to be really reliable. So we saved this next piece for the end, because we want to just talk for a minute about the Service Provider Foundation. This was a new component in Service Pack 1, really targeted, I would say, more for hosters and then, of course, customers of hosters in this initial release. Is that a fair statement?
Yeah, I'd say so. Yeah, I mean, the Service Provider Foundation is just enabling you with scenarios such as you'd like to go beyond the capacity of Pete's cloud.
Right.
He's grown too big. The demand is too high for him as a unit within his own environment. Now he wants to still provision VMs, but maybe Azure isn't in the right geography, or he doesn't want to go to that public cloud approach, but he'd rather work with a partner that he has been working with for a long time, perhaps, who's maybe offering managed services or whatever. I can use some of their capacity, but I need some way to connect those infrastructures, and that's where SPF really comes in, but presenting it through that common interface of App Controller and VMM.
Yeah, and so that's the third connect option in the app controller interface. Yep. And you see that there's a RESTful API here, so it's a web service interface that we can connect into, and then our service provider can carve up the fabric and present it to us as they like. So really at that point it's a private cloud still, but it's a hosted private cloud in this case. So just looking at the resource flow here, we're going to work with our service provider. They're going to do all of the provisioning behind the scenes and give us some sort of tenant admin role.
Yeah, and if the best way to think about tenant almost is that you are the customer of that service provider. So your application owners within your business would be those self-service users who see capacity they can use. You as a tenant admin have made stuff available to them, and the service provider admin has made stuff available to you.
Yeah, so really you're going to be providing resources to your users just for your segment of the overall cloud. So when we're talking about the world of private cloud, we were the administrators over the entire fabric. Now you're a tenant admin. You are the the master of your apartment in the building, right? So just your piece of the fabric. So there's some work to be done on the service provider side, because they're provisioning a private cloud probably on a larger scale than we might be on our own. setting up their VMM servers, installing that SPF web service. So the Service Provider Foundation web service comes within Orchestrator. At this point, it's just a little quick install to set up that RESTful web service. There's a tenant portal there. We're not going to get too much into that. That's really a hoster-specific scenario. But then you're going to plug in with App Controller using that same little connection capability. It was actually just a little further out to the right. We hit connect, we put the API in a certificate, and we're good.
Yeah. So for a customer, it's a relatively lightweight exercise to get this set up from the customer side. You know, get the certificate, send it across with the public key or with the appropriate key, and that will effectively enable you to securely communicate with the SPF layer within the service provider.
Yeah, so of all these steps that are laid out here, your service provider is going to do all of these and probably help you right up to here. So, and maybe even looking over your shoulder if you're not comfortable with the last two, which is Open App Controller, snap it in. So for you, this is very much it's a short process. So that's what I know in an hour and a half anyway about connecting to Azure from outside the console. So I'm hopeful that we're able, if you're new to Azure, if you're not experienced with Azure, that this gave you a first look into the Azure platform in a way that will help you to get started a little more easily and to connect in and be productive a little bit faster.
Absolutely, and it may, like Pete said, it may have been the first look at the public cloud service that is Azure IaaS. So it's going to give you at least now an understanding of the different bits that make it up and how you can easily, quickly deploy new VMs within cloud services, utilize the networks that are available there as well. So there's loads of cool stuff within Azure that you can really take advantage of if you just want to spin up some test environments, dev, or start to run stuff in production. Either way, you've got access to it through your MSDN subscription if you've got that within your environment, or you can sign up through just with your credit card and start to utilize the services. So pretty useful. So we're going to break. We're going to come back in around about 10 minutes. So if you'd like to join us for the last section where we're going to continue looking at some of these key capabilities within System Center and how we move you really towards that finishing off that hybrid cloud story. So thank you for joining us so far, and we shall see you in 10 minutes.